Sure. I'll pick those.
You know, flyball pencil in your apartment.
Actually,
I'm not seeing it.
I bet it
I
was
found it.
3 dollar balls.
Actually, pretty work.
I need to clean up my notebook.
Hey, did I tell you guys what I did yesterday?
Put down a tree and find
That's the trick with you.
Here, I got a picture of my, I got Alex's stuff.
chainsaw.
Took a picture of me and Mr. Blotty.
He goes by blah
Look at
blah.
that. Here, hold on, I'm gonna pass it around.
He goes by Mr. Blah blah. Mr. Blah blah blah. You should
Does
go
he
by
actually,
him.
does he know?
Yeah. Mr. Gibbs, next time you talk to Mr. Blah, you call him blah blah. Mr. Blah blah, Mr. Blah blah. Oh, really? Where's, ooh, Mr. Blah blah drives a nice truck. Oh, sheesh. Dang, blah blah. Okay.
Yeah. Mr. Blah Blah this guy. What else are we?
Mr. Blotty. Mr. Blah blah. I have
Lee
2 times a
Blotty.
day. He's,
Like
that is a
anatomy
shame.
stuff.
Anatomy, chemistry, forensics.
Someone I had him for a week.
For a week.
Wow.
Yeah, then I decided
Yeah.
I want to study law instead of anatomy.
I don't really like
I like it. He's mean to me.
Mr. Blah Blah's mean to you?
Yeah.
What?
Why? Inflex. I think it's because
You
you're
think you can go back?
Probably.
You think you can go back?
Okay,
At least make
You know, their flex is a sore loser. We beat them in man.
people often say, I don't know what logarithms are. You bring logarithms straight back to exponentials. This is a sheet right here that gives you kind of a summary of a lot of things about logarithms. Formulas that we used in our word problems last year, you're not going to need those this year. But things that you will use, you will use this. You will use this. You will use these a lot. Those are the most important part. And you will use these, and you will use these, okay? So we're going to talk about some of those basic pieces here. First, let's understand what a logarithm is. A logarithm is really the inverse function of an exponential, okay? It's the inverse of an exponential. So we can rewrite every logarithm as an exponential. How could you rewrite this as an exponential function?
Well, we need to know all these for the test.
Wait.
You won't need to have anything memorized, but you're going to need to understand how we come up with this stuff, and I think you will be able to.
This indeed will be on the test for us.
You need to know how to do this stuff, and I think it's going to come back to you pretty nicely. First of all, log base 2 of 8 is equal to 3. What does that mean?
To the third power.
Okay. And log base 5 of 625 equals 4 is?
5 to the 4.
Okay. So we're all clear on that, right?
Yeah.
So I would like to then write these exponentials in logarithmic form. Log base 3 of 9 is equal to 2. So I always, when people ask me what a logarithm is, I always say it's the inverse of an exponential. But I also say logarithms find exponents for us. Notice how a logarithm produces the exponent, okay? So in this situation, the log base 18 of 1 is equal to 0, okay? All right. What do we write the base here for this log? You don't need it because the assumed base for a logarithm is 10. So the log of 1 over 10,000 is -4. Okay, flip it over. We should be able to determine missing values within a logarithm. For example, for letter A, log base 3 of 9 is equal to x. What would x be in that situation?
2.
Yeah, because 3 squared is 9, so x is 2. Uh-oh, we have natural log of 1 is equal to x. What is natural log?
Log base.
It is the log base e. E is a number. It's a number that is irrational. It does not repeat itself. It goes on forever. Log base e of what? Of 1 is equal to x. That's how we write that, okay? So if you want to write it as an exponential, we would say base e to what power? X power is equal to 1. So what would x be?
0.
X would be 0. Okay. Letter D, log base 2 of x is equal to -4. This would be 2 to the -4 power is equal to x. What would x be? 1/16. Okay, good. So, should be able to rewrite logarithms and exponents to be able to solve for each other. We move on to this piece. We can use logarithms to rewrite these pieces as kind of expansions so that we don't have any products or division. So the log base 3 of 4x over y, what we could do is we could rewrite this, and I'm going to use this property. I'll flip back here. I'm using this property that exists right here, where you could say that the log base a of ab, I could separate the ab into 2 logarithms using addition. When I'm dividing, I could separate the 2 logarithms using subtraction, and then when I have a power, I could drop the c value. I could drop the c value right out front, as you see in that situation. So I'm going to use those laws of logarithm operations right now. So I could write this as log base 3 of 4x minus the log base 3 of what? Y. It wants no product or no power or no quotient. I currently have another product, so how would I write that? Log base 3 of 4 plus log base 3 of x minus log base 3 of y. Good. That you're going to use a lot this year. Okay? Try letter B on your own. Got natural log of 8 plus 3 natural log of 8. Very good. Any questions how I got the 3 up front? Okay, we move along. I'm going to try letter D. What do you want to do first? You give me a thought. What do you want to do first?
Square root of 2y to 2y to the 2/3 or 3/2.
Good. We're going to go log of 3x squared times the quantity 2y to the 1/3 power.
Break it up with multiplication.
Okay, so I have the log of 3 plus the log of x squared plus the log of 2y to the 1/3 power.
1/3 out front.
So I could drop the 1/3 out front and the 2 out front. Log base 3, log of 3 plus 2 log of x plus 1/3 log of 2y. And as you can see here, we need to split the 2y apart as well. So log of 3 plus 2 log of x plus 1/3 log of 2 plus 1/3 log of y. What do you think? Remember it?
Yeah.
I would say most typically you're going to see problems that would have, say, this shape or form or this shape or form. Just having that basic understanding, you can separate into addition or subtraction. That's what's most important, okay? All right, now we want to rewrite them as a single logarithm, So as I look at 5a, Instead of having two natural logs, I want just the natural log of, anybody know what it's gonna be? 30. Because we take 120 and we divide it by 4. Okay, so your row is 120 over 4, which is 30. Try letter B on your own. See if you do letter B on your own. Try to write it as one logarithm, log base 7 of something. I got the log base 7 of x cubed y squared all over 4. Did anybody put the y squared in the denominator? Do you see why the y squared cannot go in the denominator? Notice how this is negative, so where does the 4 end up? In the bottom. This is positive, so it's in the top, and this is positive, so again, it's in the top. Yes?
What if I wrote log to the 7 and then x cubed over 4 y squared?
Like that?
Yes.
Yeah.
You would not block points?
No,
Okay.
that's technically correct. But I would ask you, why didn't you put the y squared up there with the x cubed?
Because I didn't think of it.
Okay. You do you. Flip it over. Do you remember how to solve exponential equations? Like 5 to the what power is 30? I mean, I know that 5 to the 0 power is equal to 1, and 5 to the first power is equal to 5, and 5 to the second power is, and 5 to the third power is 125. So it looks like if 5 to the x produces 30, that the value of x needs to be somewhere between 2 and 3. Would everybody agree? So the way you solve for this is you get rid of 5. We don't divide by 5. We don't subtract 5. We don't take the fifth root. We take the log base 5 of both sides. So the actual operation that occurs is this. We take the log base 5 of both sides. When you do that, what remains on the left-hand side? You get just x. And then you have the log base 5 of 30. Do you remember on your calculator how to produce the value of log base 5 of 30? We take the log of 30 and we divide it by the log of 5. Okay, so let's make sure you can do that. Take out your calculator. I take the log of 30. This is your change of base formula. And we divide it by the log of 5. And we said we should come up with a number between 2 and 3. We had 2.113. Okay. See if you can solve letter B on your own. Try letter B on your own. Is the Wicked Witch of the West a vegetarian too?
She's not.
Just want to know what I'm dealing with. Hopefully you came up with 2 to the x is equal to 47, and if you took the log base 2 of both sides, what did you get for x?
5.55.
5.55, sounds good. Good with that, Hannah?
Mhm.
Okay, we don't need to worry about the next 2, but suppose we have a logarithmic equation. I'd like to try a couple of these.
Yeah, 47.
Okay. Log base 3 of x is equal to 2. I want to get rid of the log base 3 of x. Anybody know what I do to both sides?
E.
I create a base of 3 on both sides. That is the inverse operation. 3 to the log base 3 of x makes those go away. I'm left with just x. And what do I have on the right-hand side? 9.
Good job, Lily.
Try letter H on your own. Try letter H on your own. Rocking the Puma today. Should we put a keyword in the video to see who watches it first?
Sure.
What's the keyword?
Puma.
Puma. All right, so of those who are absent today, whoever sends me an email with the word Puma or says Puma to me in class, you will get a little W snack.
Puma.
Bunch of cheaters. No, don't tell them. See if they watch it.
Who's even gone?
Louise will not watch it.
Luis is not gonna watch it.
I was just airing.
Here.
Oh, watch it.
Okay, I divided by 4. Then I create a base of 6. I've got x minus 3 is equal to 36. Add the 3, you should get x is 39. Did you get it? Isn't it amazing what you remember? Jordan, you good? Jojo, Siwa?
Yes, I am. I just forgot you could do that.
Wait, isn't there instances where we can't use that, or am I making that up?
Give me an example.
I don't remember, I just feel like last year you told me I was wrong for using it one time.
Trying to think what I'm trying to think of that situation. I can't think of it. If we come up with it, so be it. How would you solve this one? What did you do both sides?
-7.
Subtract 7, and we get 2 natural log of x is equal to 1. Divide by 2, get the natural log of x is equal to 1/2. How do I get the natural log to go away? I create a base of e in order to make natural log go away. Good job, Hannah.
Thank you.
And so what is left is x. And what does it mean to take something to the 1/2 power?
Square root.
Yeah, so you could just write this as the root of e. That's your answer. You good with that? All right, flip her over. I would say that the graphical knowledge may be the most important aspect that you try to remember, okay? We have exponential functions. Y is equal to 4 to the x. Do you remember what that graph looks like?
Or am I thinking of something else?
The graph looks like this. It has a horizontal asymptote of y is equal to 0, and then all of a sudden it gets rather large. It's kind of like if you were to look at our national debt over its history. Say exponential, okay? It used to be like billions, now it's trillions, right? It's like,
I don't understand how
I don't understand that.
everyone's in debt.
Do you know what
Yeah.
makes sense to
Like
me?
every country is basically in debt.
yeah, this is a good point. There's a big debate about how much national debt actually matters. You know what I mean? Does it matter?
Just do
debt seems to matter when you compare it to the number of assets you have. So for example, I have debt, I owe debt on my house,
Right.
but the house also counts as value, you know?
I see, I get it like on like a normal level,
Right.
but like a national level, I don't understand.
Well, let's say that, I don't know, Jamaica wanted to buy the United States. What would we charge? No, I'm kidding. Hi!
So, if we're all in debt and we have the ability to print money, how does that cause more problems?
You have to pay for it.
That's a really good point. I would love to talk about that because I mean, this is a big issue, but we don't have time for that, no. But,
Okay.
We are.
But all your money,
and
so everyone has more money, then the cost of things go up. So
Yeah.
that
Yeah.
Doesn't make sense.
Money doesn't have the same value.
and without a doubt, when you just print money, it just devalues it
But I
entirely.
don't understand that.
The
Well,
more
if you
you
look at
have, the
countries
less
like
valuable it
over
is.
there, like $1 is like 17 million
That's
in
an
their
easy concept.
things.
Yeah.
Because they just devalue it.
Okay, so let's get back to this
Sorry,
piece.
over there.
Sorry, I said national debt. Sorry. That's what the shape looks like. Now, what's really important about this is do you understand why? Do you understand why it goes through this coordinate right here? What is this coordinate? 0, 1. Why does it go through 0, 1? Anything to the 0 power is 1. Did you notice that the graph never goes below the x-axis?
You did tell us that.
Why?
Because if you
Because
square
it's
it,
You can't swear.
Because if you take, say, 4 and you raise it to the -3 power, for example, does that give you a negative value? It does not. It gives you 1/64. So if you take a number and raise it to negative values, it doesn't make it negative, it just makes it smaller, right? So it's important that you understand that conceptually. Do you know what happens if it's 1/4 to the x? Why? Here's why. 1/4 is the same as 4 to the -1. Agreed? So therefore, this is 4 to the -x. That creates a horizontal reflection. Okay? So very okay with that? Okay, if you move down to G, how is G different? It's a logarithm. If you know the graph of an exponential, you should know the graph of a logarithm. Help me out.
let's put it in a calculator.
Instead of a horizontal asymptote, it has a vertical asymptote.
Oh, you're so right.
Instead of going through the coordinate 0, 1, it goes through
1, 0.
1, 0. And so within that, we learn some very important pieces. And this is something you want to try to keep in mind because you'll continue to ask me throughout the year, and I will answer your question, but I want to be clear. This means that the log of 1 is equal to 0. Notice the x value is 1 and the y value is 0. Similarly, the natural log of 1 is equal to 0. It doesn't matter what the base is because these are saying the same thing, which is 10 to what power is equal to 1? 0. These mean the same thing. And this means e to what power is equal to 1? 0. That's what this means. Okay? Second of all, can you take the logarithm of a negative number? It does not produce, you don't have any negative values that produce outputs, do you? And if you ask me why, I will bring it back to this. It's because it's the inverse of that. Notice how you don't get any negative values out. So in this situation, you can't plug any negative values in. Logarithm graph, the exponential graph, and some key values. So that's the best I can do for you on a little bit of review. If you don't have any assignment, you just need to finish up the work that you have in hand. What day do you test?
Tuesday.
Not
Tuesday
next
before?
Tuesday, next Tuesday.
Thanksgiving break.
Thanksgiving, okay? And if you get all the first problems right, I will issue you your first driver's license.
Hey, Lily.
Rhea, how excited are you to receive your first driver's license?
Lily needs to see you.
Should we take pictures of everybody before, like when you go to the driver's office, you have to get your picture taken, right? Maybe we should have a day where people get their pictures taken for their driver's license. Okay, we're gonna do that. Yeah, we're gonna give you guys a fair warning ahead of time.